So 7.5 and 7.6 are really just about more trig identities. And we're going to be doing several things with them. Once we know a trig identity, we're just going to try and apply it, or we'll see it in an equation like 7.3, or we'll see it in prove the identity, or establish the identity like the book says. So, and there's quite a few of them, but hopefully, we don't have to memorize them at this point. You should have them memorized by the time you take Calc 1. And then, and then you'll, after you have them memorized, you'll see how we use them in calculus. We're always constantly trying to simplify answers, simplify functions, and it's these identities that help us do it when it's a trig function. So our first one is the sum and difference formula. There's a nice proof in the book. I would ask Ben to take a look at that. I'd be happy to go through it with you. Maybe the computer science students should look at it too. But the biochemistry and engineers don't bother. So our first sum and difference formula is for cosine of alpha plus or minus beta. So what I'm talking about now is I have two angles, right? I've been dealing so far just with a single angle. So now I'm using two Greek letters for my two angles, alpha and beta, right? And so the identity here is, this is cos of alpha times cos of beta minus plus sine of alpha times sine of beta. And so the important thing is, if I use the plus on the left side of the equation, I use the minus on the right side of the equation, okay? And vice versa, right? My other identity is sine of alpha plus or minus beta. And on that one, I do sine alpha cos of beta plus or minus cos of alpha sine of beta. So in this one, I can really see that I don't switch the signs. On the first one, I switch the signs, right? On the second one, I keep whatever sign I use on the left, I use on the right. So that's our next set of identities on our formula sheet. And let's see how we would possibly use it, right? So I might say something like, let me do a problem here from the textbook. I hate this stupid Math Excel. Sorry. Oh, I recorded that. Give me a second, please. Well, I actually can show the homework page, because, so are we looking at the homework page? Can you look at the homework page with me? Even though it's going to fail me in 7.6, so I'm looking at 7.5 right now, like number 19. Can you look at that for me? It says cosine of 7 pi over 12, right? And I want to solve this without using a calculator. I want to use I want to use my reference angles. And on the side of things, I'm either going to use reference angles, or I'm going to make you draw a triangle. Okay, that's the only thing that's going to happen. I'm not going to have you go to a calculator at all. So use the reference table or go use a triangle. So in this one, I want to write this as cos of as alpha plus or minus beta. I don't know which one it is yet. I can see this one quickly as a 3 plus 4. right? It's 3 pi plus 4 pi is 7 pi. And so why does that work out well for me? Because I want everything to turn into reference angles, right? I want everything to turn into reference angles. So you can see the 3 and the 4 are going to simplify to pi over 4s. And the 4 and the 12, sorry, the 3 and the 12 are going to simplify to pi over 4. The 4 and the 12 will simplify to a pi over 3. And that's what I'm trying to get. A 0, a pi over 6, a pi over 4, a pi over 3, a pi over 2. Right? You with me?
Yes, Rosemary.
So now I'm going to use my formula. I'm going to use the positive on the left and the negative on the right. You notice they're at the same level, right? So I did that on purpose. So I'm going to get, I can simplify this first, right? This is what cos of pi over 4 plus pi over 3. So my alpha is pi over 4, my beta is pi over 3, right? So cos of alpha, cos of pi over 4, times cos of beta, pi over 3, minus sine of pi over 4, sine of pi over 3. Is everybody with me? I know it's a little weird. It's not difficult. It's just new, right? We okay? Elise is good. Anybody else?
I'm good.
Ryan, Wilder, Ben, nice. Cindy,
Good,
thank
Ben.
you. Thank you. Manish, nice. So cos of pi over 4 is rad 2 over 2. Cos of pi over 3 is 1/2. Sine of pi over 4 is rad 2 over 2. Sine of pi over 3 is rad 3 over 2. It looks like I can factor out a rad 2. I can factor out a 4. So I get rad 2 over 4 times 1 minus rad 3. And there's my answer. And what's nice on those, you can check with your calculator, right? You can check with your calculator. Obviously, I'm going to get a negative here, right? I'm going to get a negative answer here, right? Why is it obvious?
Because of the root 3.
Yeah, root 3 is bigger than 1. And 7 pi over 12 is in quadrant 2, right? So I'm cutting this into 12, right? I'm cutting pi into 12, and 7 pi, 1, 2, 3, 4, 5, 6, 7. 7 pi over 12 is in quadrant 2, where cosine is negative. Right? So you have little double checks like that, and you can use the calculator, right? Anybody want to see me check it on the calculator?
Please.
Yeah. So I'm opening my calculator here. It's a little bit hard to see, but let me make sure you know. So I'm doing cosine of 7 times pi divided by 12, right? Yes, you can see that okay? So I get a negative, about negative 2.26. And then I want to check my square root of 2 divided by 4 times 1 minus rad 3. And I should get the same answer, right? Done. There's nice little calculator tricks for all of this trig stuff so you know you're right. Of course, graphing helps too, right? Nice. Let's see if we do another one here. Let's do, and I'm looking at, again, 7.5 homework. Let's do 23. Secant of minus pi over 12. I just did one with sine, right? Is that true? Which one did I just do? Oh no, I did 19 with cosine. Let me do one. Yeah, let me do one with sine. Sine of 5 pi over 12. Let me see if I could do, I can make this a sine of alpha plus beta, or I can make it a sine of alpha minus beta. Let me see if I could do an alpha minus beta, right? Let's see if I can make this a sine of alpha minus beta. So I now want to be thinking of two numbers that subtract to 5, and they reduce with 12. So what reduces with 12? 2, 3, 4, 6, 8. So you see I have lots of options, right? So 2, 3, 4, 6, 8, any of those subtract to 5. What did I say? 2, 3, 4, 6, 8 all divide with 12, right?
Yeah.
Of course, a 1 and a 12 do too, but 9 does too, right? So do any of those subtract to 5? Hello?
8 and 3.
Fine, 8 and 3 or 9 and 3. Yes, so do it. If I do 8 and 3, you should try 9 and 5. So we're talking about sine of 8 pi over 12 minus 5 pi. 8 and 5, 3 pi over 12, right? That's what we said, right?
Yeah.
8 and 3 or 9 and 5. 9 and 4. I can reduce those first, and I will do that. So sine of 4 goes into 8 twice. So 2 pi over 3 minus pi over 4. Beautiful. So I'm going to use my sine of alpha minus beta. Right? Just a reminder, what is sine of alpha minus beta? It's sine of alpha cos of beta minus cos of alpha sine of beta. Yes, I have it memorized because I've been doing it for 30 years. I tell you, if you practice for a couple of days, you'll have it memorized. So I need sine of 2 pi over 3 cos of pi over 4. Notice I'm not taking the sines of the angles. I just take alpha and beta and let the SIGN in between determine the formula I'm using, right? So minus cos of 2 pi over 3 sine of pi over 4. All right, well, sine of 2 pi over 3, that's in quadrant 2. That's rad 3 over 2. Cos of pi over 4 is rad 2 over 2. Cosine of 2 pi over 3 is negative. It's in quadrant 2, so it becomes positive 1/2. And sine of pi over 4 is rad 2 over 2. That looks like I can factor out a rad 2. I can factor out a 4. And the stuff I have left, so I have rad 2 over 4, and the stuff I have left again is 1 plus rad 3. Pretty easy. Just, you got to practice. You got to jump in there and do it. You can't just watch me do it. You got to do some problems. Say, kill the tree. We don't care about, we don't care about the tree. After you become a engineer or a computer scientist or a doctor, and you're making hundreds of $1,000s a year, just go plant a couple trees to make up for your calculus sequence. So there's a bunch of problems there to do. If I look at that page, and I'll share that page real quick again. This is that homework sheet I gave you for 7.5. Don't do the things with the degrees. I'm not going to give you anything with degrees. I didn't give you the sum and difference formula for tangent. You certainly can look at the book and do them if you want to, but I'm just going to give you sines and cosines. There's some nice ones here. Establish the identity. Let me just give you one that's not on here, but these are all good to do, right? Like 7.3 again. Every time we learn a new identity, you should be able to prove identities. So let me do one like that, and then we'll jump down to 75 to 92. So there's two more identities that we really should know, but they're obvious, and when you see them, you don't have to bother. You don't have to have them memorized. You don't have them on your formula sheet, because you can see this is a cos of alpha minus beta, right? And then sine of pi over 2 minus theta is cosine. So these are in the book. You could put them on your formula sheet. You don't really need to do that, because once you know the cos of alpha minus beta or the sine of alpha minus beta, then these are all obvious. What does this thing say? What does this thing say with our current knowledge? What does this thing mean with our current knowledge? What are we doing with the cosine curve?
Amplify.
Not the amplifier.
Frequency.
Not the frequency.
You're shifting it
Shifting it. Which way?
to the left,
Almost.
to the right.
Yes. Remember, x's behave inverse. The insides behave inversely. So what do I need to put in there to make it 0 in the inside?
Plus pi over
Yeah,
2.
plus pi over 2. So I'm going to take my cosine curve, can you see it already? And shift it over to the right by pi over 2, and look what it becomes. Shift it to the right, 90 degrees. What does it become? Sine curve. It's the sine curve, right? The cosine curve, and remember I just added this little piece here, right? If I take that piece and move it over, I'll superimpose it now. You can see the cosine curve here, right? So, but the cosine curve keeps going over here, and now you can see that the cosine curve shifted right by pi over 2 becomes the sine curve, right? And that's that relationship. Remember I was talking about that? What's that relationship, right? With the sine and the cosine. But anyway, cos of pi over 2 minus theta becomes cos of pi over 2 cos of theta plus sine of pi over 2 sine of theta. And what's cos of pi over 2? Look at the cosine of pi over 2. What's cos of pi over 2? Hello? What's cos of pi over 2? What height? 0. What's the sine of pi over 2?
1.
1. So I just get sine of theta, right? So there's nice little identity problems to do there. Again, do the ones with sines and cosines. If you want to do one with a tangent, you could either look up the tangent identity, or you can use a sine identity over a cosine identity, which is a lot more work. Let's do something from 81 to 86. Anything look interesting there? Why don't I really like 81 for you to do? No, 81's fine. Inverse tangent's fine, right? I don't like inverse cotangents, inverse cosecants, inverse secants, okay? I'm not going to give you any of those. In fact, even in Calc 1, I restrict everything to sine, cosine, and tangent. Just because it's so much material, right? How could anyone do all of this? I don't know. I did it. But the more and more I teach, everyone keeps telling me students can't handle it. So, man, I'm starting to believe them. So, let's do... Let's do 86. Why is So this is 7.5, number 86. The tangent of the inverse cos of 4/5 plus the inverse sine of 1. I want to figure out what that answer is, question mark. Well, every time I see an inverse trig, I'm thinking an angle, right? Every time I see an inverse trig, I'm thinking an angle. So I'm going to let alpha equal cos inverse of 4/5, which means cosine is what? Cos of alpha is what?
4/5.
Nice, which means I have a triangle with an adjacent side of 4, a hypotenuse of 5, and by Pythagorean theorem, the other side is 3. Does anybody need to see the Pythagorean theorem there?
No, sir.
My chat is open if you don't want to say it out loud. So beta, I'm going to let equal inverse sine of 1, which means sine of beta is 1. And of course, I know when sine is 1, that means beta is pi over 2. Right? There are more answers for sine equal to 1, but we want one in quadrant 1 or quadrant 4, inclusive, right? Nice, so I really have tangent of alpha plus beta, right? So I really have tangent of alpha plus pi over 2. Oh shit, I didn't want to use the tangent. Let's see what happens if I use the sine and cosine, right? So I really have sine of alpha plus pi over 2 over cosine of alpha plus pi over 2. This is good for you to be able to do this. So what do I use upstairs? I use my sine of alpha plus beta. And for downstairs, I use my cos of alpha plus beta. So upstairs, I get sine of alpha cos of pi over 2 plus cos of alpha sine of pi over 2. Is everybody with me? Downstairs, I get cos of alpha cos of pi over 2 minus sine of alpha sine of pi over 2. And again, I just have it memorized, but you're going to have it on your formula sheet. Damn it. Cos of pi over 2 is 0, right?
Yeah.
So I just have, and sine of pi over 2 is 1. So I really just have cos of alpha over sine of alpha. And I get both of those from my triangle, right? Alpha was here, right? So I get cos is 4 over 5, sine is 3 over 5. So I get 4/3. Nice. This stuff is easy and fun. I know. You might think I'm a little crazy if I say it's fun, but I think it's fun. Again, you're playing a game with your nieces and nephews. You know, you're gonna sit there and be miserable, or you're gonna pretend you're having fun. So yeah, on this page, on this problem.
Yeah.
You want the whole thing at once, or you want it in 2 pieces?
Oh, once is fine.
Okay.
How'd you get 4/3? I got 5/3.
Right here. Where?
No, the final answer. You got 4/3. But I got 5/3.
Oh yeah, because I did a wrong answer for sine. I was rushing. Sine is 3 over 5. Sorry.
Oh.
Right, so I get 4 over 5 times 5 over 3 is 4 over 3. I knew the answer. I was rushing to the answer. And I forgot to. That's where we make mistakes, right? That's why accidents happen close to home, because you start thinking about, oh, what are you going to have for dinner? Or am I going to miss the first pitch or whatever? And you stop thinking about what you're doing driving. And you start rushing. When you start living in the future instead of living in the present, That's when you make mistakes. All right, let's look at that next set of homework problems there in 7.5. 87 to, I like 87 to 92. I don't really like the other ones. I don't really like these. I mean, they're okay to do, but I'm not going to ask you one, so let me just make it a little bit easier on you. Don't do any of these. So 87 to 92, they're all looking good to me. The only one I probably don't, I like them all because there's no inverse, secants, cosecants, or cotangents. So I guess let me do 92. The secant of the inverse tan of u plus the inverse cos of v. I'm going to write it down in a second, so don't be in a rush, but it's 7.5, number 92. You have that PDF on your side. So I have the secant. What's going on with my pen? Come on. What's going on? What's going on? Please. Don't do this to me. Oh, just crashed. Where? Oh, I never wrote it. I've got the secant of the inverse tan or arctan of u plus, oh my god, I have a meeting at 1 o'clock. Are you kidding me? I'm so tired. Anybody else burnt out?
A little bit.
So what do I do? What's my idea? Yeah, I know. We're all burnt out. That's when Thanksgiving break just comes just in time. So what do I do? I see inverse trigs, what I want to call them angles, right? So I'm going to use alpha for inverse tan and beta for inverse cos. Both of them give me, so I have an inverse trig, I get an angle. The angle gives me a trig. So I know tangent of alpha is u, and I know that cos of beta is v, right? Both of those give me a triangle. So for the tangent with alpha as my angle, I get u over 1. Remember, tangent is opposite over adjacent. So u over 1 is u. And I get the other side by Pythagorean theorem, 1 plus u squared. Does anybody need to see that Pythagorean? And then the other one, I get a triangle with an angle of beta. And cosine is v over 1. So adjacent over hypotenuse. And the remaining side is square root of 1 minus v squared by Pythagorean theorem. Is everybody okay there? Anybody want to see that? I don't mind showing it. Now I have the problem, right? Secant of the arctan of u plus the arc cosine of v is actually secant of alpha plus beta. But I don't think in terms of secants, so I should realize I have 1 over the cosine of alpha plus beta. Right? Secant is reciprocal of cosine. I don't think in secants. I think in cosines. So I have to use my formula for cos of alpha plus beta here, which is cos of alpha, cos of beta, minus sine alpha, sine beta. Again, I just have done so many problems, maybe 17 million in the last 30 years that I have it memorized, right? So I'm going to get cos of alpha and cos of beta from my triangles. Same thing with sine of alpha, sine of beta. So what do I get here? Cos of alpha is what? 1 over square root of 1 plus u squared. And cos of beta is v over 1, right? Is everybody seeing that? I'm getting my cos of alpha from here, cos of beta from here. We okay?
Yeah, Roger.
Minus sine of alpha. So sine of alpha is u over square root of 1 plus u squared times sine of beta, which is square root of 1 minus v squared, right? And I'm getting those from here. Now, a big theme of what happens in the calculus sequence is that if you have more than one fraction, get me a single fraction. If you have fractions within fractions or more than one fraction, get me a single numerator factored and a single denominator factored. And so this one is pretty simple. I get 1 over v minus u square roots of 1 minus v squared over the square root of 1 plus u squared. Right, I can already see I have a common denominator there, and I just do my keep change flip. So square root of 1 plus u squared all over v minus u times square root of 1 minus v squared. And there's the answer. Nice, there's 7.5. Sweet. Nice and easy. This stuff happens a lot in calculus. That's why we're showing it to you now and let you practice now. Because what's going to happen after you simplify this, you're going to take a derivative. What does that mean? It means a difference quotient when you let h go to 0. You're going to be doing that so many times in Calc 1. And you might hate me right now, but you will thank me next semester. And I don't care if you hate me for the rest of your life. I wouldn't blame you. My ex-wife will. But the idea is, hate me, but be prepared. Hate me, right? Despise me, but be ready for your next class. That's all I care about. I don't care if you hate me. I'm human. A lot of people hate other humans.
How can we hate you, Professor, if you try and prepare us for our next class?
Well, yeah, sometimes it's you know, I wasn't too happy with my dad when he would beat me because I did something wrong, but at least I didn't go to jail, or at least I didn't get caught. You know, what? Go ahead.
No, mind. I was just kidding.
It's hard not to say something you shouldn't say, right? All right, here we go, 7.6. In 7.6, we have 3 sets of identities. I'm going to only hold you to 2 of them. This is the double angle identities, power reduction. We do those in Calc 2, so that's the one I'm going to skip. And then the half angle identities. Let me write them all down first, and then we'll see how we use them. And I screwed up a little bit on the homework in 7.6. I left out the double angle identity problems. So I'm gonna just make a little separate set and send it to everybody, hopefully today. Okay. So here are my double angles. Sine of 2 theta is 2 times the sine of theta times the cos of theta. Memorize that one. Cos of 2 theta is sine squared theta, cos squared theta minus sine squared theta. Memorize that one. There's 2 more, but those can be easily derived. I know that cos squared can be 1 minus sine squared, right? And I know that sine squared can be 1 minus cos squared. So I get 2 more identities here. This one becomes 1 minus 2 sine squared theta And this one becomes 2 cos squared theta minus 1. So what I'm saying is these two you can memorize. And then the last two can be derived. Okay? So they're easily proved. So if you only have the the sum and difference memorized, then you can get these as well. So I'll derive the first one, right? Sine of 2 theta. And don't let me go too fast here. I feel like I'm going too fast, but nobody's telling me anything. But don't let me go too fast. Am I going too fast?
No. Okay.
So sine 2 theta is sine theta plus theta. So you can see I turn it into an alpha plus beta problem, right? And so this is sine of alpha, cos of alpha, plus cos of alpha, sine of alpha. And you can see I have 2 sine alpha cos alphas. And there it is. 2 sine theta, cos theta. Done. Easy. So a typical problem that I left out of the homework is this. If I say to you that sine of theta is 1/4, find sine 2 theta and cos 2 theta. So what do I know if I know this? What do I know? If I know sine of theta is 1/4, what do I know?
You're gonna put it in inverse.
I know a triangle. So I know that the opposite side is 1 and the hypotenuse is 4, and the remaining side is what, rad 15, right? We did that already today. So sine 2 theta is 2 sine theta cos theta, right? So that's 2 times 1/4 times rad 15 over 4. Right? So once I get my triangle, use my identity to reduce it down to sines and cosines, and then use the triangle. So it looks like what, rad 15 over 8? Done. Here's another typical problem. Oh, I forgot cos 2 theta. So cos 2 theta turns out to be cos squared theta minus sine squared theta. Why do I know that middle sign can't be positive? What helps me remember that middle sign can't be positive?
Sine isn't odd.
Say it again.
Sine isn't odd.
Sign is odd. What if that middle sign was positive?
Meaning the angle is negative.
Then I get cos squared plus sine squared, which is always what?
Over 1.
Always 1. So I can kind of remember that middle sign's got to be negative, can't be positive. So anyway, here, what do I get? I get rad 15 over 4 squared minus 1 over 4 all squared. So I get 15 over 16 minus 1 over 16. Whoops. You get 14 over 16, which is 7 over 8. My power reduction formulas, which I'm just not going to do at all. I'm going to wait for them for Calc 2, okay? So the power reduction formulas are sine squared theta. Don't tell me. Forget. Give me a second, I'm just looking it up in the book. Sine squared theta is 1 minus cos 2 theta all over 2, and cos squared theta is 1 plus cos 2 theta all over 2. There's a nice, when you get your textbook, and I would suggest buying the book. The first calc book is Calc 1 and Calc 2 in one book. Okay? So whether you're a bio major, chem major, computer science major, engineer, math major, you're going to use that book for 2 years. It's nice to have that book, especially because the first page is everything you should know from pre-cal, and it's a tear out, like a formula sheet. And the last 4 pages are everything you're going to need to know through after Calc 1 into Calc 2. So it's kind of nice to have that if you buy the physical book. But these are you need in Calc 2. We don't really use them in Calc 1. But they do derive for us the half angle formulas. And so sine of theta over 2 is plus or minus square root of 1 minus cos of 2 theta all over 2, and cos of theta over 2 equals plus or minus square root of 1 plus cos 2 theta all over 2. So there are our half angle formulas. And you can kind of see, and you don't have to, so don't look too much. You can kind of see the relationship between oh, I'm sorry. I think it's just cos of theta. Yeah, let me just double check. Sorry. You can see the relationship between the power reductions and these. Don't look too hard, okay? Because we'll make sure you get to Calc 2 before we start torturing you with Calc 2 stuff. Yeah, I got it right. I shouldn't have had the 2 theta. Yeah, this is it. So these are the ones that I'm going to ask you to put on your formula sheet, the half angle formulas, not the power reduction. You'll use the power reduction in Calc 2. So let's look at a typical problem. Now, what's the weird thing about these formulas? What do you see that's kind of weird? That kind of doesn't really instantly make sense. I mean, you don't know the formula at all, right? But you got to trust me on that. But when you look at it, there's something that's kind of weird in there.
We both have cos, nothing on sine.
The plus minus, right? Is that what you said, Ryan? Is that what you're saying?
No, I said that nothing has sine, like they both have cos.
Oh, I get you too. All right, well, I ruined it then. It's that little plus minus, right? And so I have to be thinking like if it's, so if I know, right, if I know theta over 2 is in quadrant 1, then sine of theta over 2 is positive, right? Yes? If I know theta over 2 is negative, then sine of theta over 2 is negative, right? So I'll pick, based on where theta over 2 is, and which trig I'm using, I'll pick the positive or negative piece for it, right? Does that make sense?
Got it.
So there's a visual there that you're kind of forced to find before you do the problem. But of course, if you check it on your calculator, it'll just give you the sign, right? Like if I gave you sine of minus pi over 8, and I said find the exact value, well, you could just do this on your calculator right away and know that this particular piece is negative, okay? Right? Wouldn't it make sense that if it was negative pi over 8, that I'd be down underground for the sine function, right? Sine, remember, sine is a height. But I want to use my half angle here. So I want to see this as sine of 1/2 times some theta. And so what's got to be in there is minus pi over 4. Right? You see that? And guess what? I'm, again, always trying to turn these into reference angles. Okay? So now I know I'm going to be using the negative version of square root of 1 minus cos of negative pi over 4 all over 2. Everybody with me? Anybody else? Nice Ben's with me. Anybody else? Jamal, Thuria, nice. Wilder, Cindy, Brian, Manish, nice. Oscar's there too. Wow, nice. So I get negative square root of 1 minus rad 2 over 2. Remember, cosine's even. So whether I put a negative argument in or a positive argument in, I'm going to get the same result. All over 2. And I want to make this, I guess, I have fractions within fractions. If that's the case, I want to try and simplify them. So I'm going to do a 2 over 2 here. And I'm going to get a negative square root of 2 minus rad 2 all over 4. So negative square root of 2 minus rad 2 all over 2. And that's the nice answer there. And what's nice about this is you can check it on the calculator. Right? Do you want to see me check it on the calculator?
Yes.
So on the left-hand side, I have sine of negative pi over 8. So on the calculator, sine of negative second pi divided by 8. And I get about a negative 0.3. Sorry, 38, yeah. And I'll do the solution I got, which was a negative square root of 2 minus square root of 2 all divided by 2. And I should get the same decimal, and I do. That's a nice way to check. So lots of the only thing I don't have is the double angle problems. I owe you those. Those are up before number 21 in 7-6. So there's some pretty cool problems to do here, but you know, do them all. Let me see if I do 72, and then we'll quit for today. I'm supposed to be in a meeting at 1. I don't know how I get a meeting scheduled when I'm supposed to be teaching, but 70. What did I say? 72? Yeah. So I've got the cos. Oops, sorry. I'm just looking. I know you can't see the page, but I'm just writing it down now. Cos of 2 theta equals 2 minus 2 sine squared theta. And the book is always asking for solutions from 0 to 2 pi. I'm asking you for every solution. So plus 2k pi kind of solution. Well, I don't know what to do here, but I do know I don't like the double angle formula. So I'm gonna change it to something. I'm gonna change it to the one I know, right? The one I know is cos squared of theta minus sine squared theta equals 2 minus 2 sine squared theta. And I'm thinking that I've got everything in terms of, wait, did I make a mistake there? Sorry. Let me just make sure I have the right problem written down. No, that's it. I'm thinking I can get everything in terms of sine squared, so that's what I'm going to try and do. So I know my cos squared is 1 minus sine squared, right? And I know I'm trying to solve this for sine now, right? So I'm going to try and put everything I can together I'm seeing an issue right away. What the hell's happening here? I'm seeing something bad happening. Do you see it?
What is that?
I don't know if I made a mistake somewhere. Or if I wrote the problem down wrong. That's what I keep thinking I'm doing. No, I didn't write the problem down wrong. I feel like there's a mistake. So what I'm going to do is I'm going to cheat. I'm going to go to my solutions for chapter 7. And this is how I got through myself through school. Is if I was working on a problem and I didn't know if I was doing it right, I would take a quick peek at the solution, right? Take a quick peek at the solution and see if I was going the right way. 7.6, number 72. I'm just scrolling through the solutions till I find it, and then I'll let you look at it. 7.6, number 72. I'm thinking there's no solution to this, but I think I must have made a simple mistake. No, it's it. So you can see I got the same thing on both sides. They just cancel. So I get 1 equals 2. Can't happen, right? So there's no solution. The scary thing is if 1 equals true was correct, then if 1 equals 2, then Kuhar is the Pope. That's kind of scary if you knew my background. So there's Kuhar, and there's the Pope. And he's got that funny hat on, right? And so how many people are in the room, right? Only one person in the room since 1 is 2. This was all a joke, by the way. You know that, right?
Yeah.
Okay. I'm losing it. All right, we're done for today. Yay. Done. Get some homework done. Have a good weekend.